Next up, we have Dr. Lauren Deus, who got his bachelor's in anthropology at Oregon State University, his Master of Arts in interdisciplinary studies in anthropology at Oregon State University, his PhD in anthropology at University of Alberta. He's directed several teams all over. In Baja California, they discovered evidence of earliest deep sea fishing. On the Oregon coast, they observed early people's migration routes. In the northern Great Basin, they discovered people had lived there as early as 14,450 years ago. In the lower Salmon River Canyon, they have the earliest radiocarbon dated evidence of humans in the Americas at Cooper's Ferry site in Idaho. Of course, his work right here in the Corvallis, where they dug up the mammoth bones from under Reser Stadium. They were estimated to have been here for over 10,000 years. He's currently the executive director of Keystone Archaeological Research Fund, and they look to further understand the Western North American history from over 12,000 years ago. Without any further ado, we have Dr. Lauren Deus.
Well, hello, everybody. Thanks very much for inviting me to be a part of this group, this event. And as you can see, I'm in a pretty nice place right now. I don't know, this whole situation isn't entirely bad if you can get a fake background. So, what I wanted to talk to you all about today is just to sort of give you an idea about, in a way, sort of the way an archaeologist might view some of these places that are familiar, I think, to everybody. So I work, in addition to those places that John mentioned, I also work on the Oregon coast, or maybe he mentioned that, but I work on the Oregon coast as well. And I essentially try to find places where there's evidence of people's living in areas and they left things behind for us to find. And so I'm not sure what everybody's background is, but I think we're probably a pretty multidisciplinary group here, probably lots of people from lots of different backgrounds. And one thing about archaeology that's important to know is that archaeology is sort of about everything when you think about it. If you're trying to understand people's lives of the past and the things that they were doing and the world they were living in, you've got to be able to understand things about biology and geology, cultural aspects, zoology. So those are all skills that really sort of help us, do what we do. So today, what I want to share with you is, again, sort of a perspective on how an archaeologist might view a certain area. So I'm going to focus on Newport, and I've begun to have a conversation lately with Oregon Parks and Recreation Department, and also talking to the Siuslaw National Forest. So the Siuslaw National Forest, if you don't know, manage the pieces of ground that are sort of around the Florence area, the really big sand dune areas. And Oregon State Parks have parks up and down the coast. And there's a lot of archaeological material that's inside these parks that are in buried contexts. So for me, it's not enough to just simply go and work on any old kind of archaeological site. I need to sort of keep it in line with my focused interests. And as we heard earlier, I'm really interested in looking at the earliest time period. So let's go ahead. I made a little PowerPoint presentation and we can jump into that. I can give you an idea of what I'm talking about. So one thing it's a theme that runs through this is that Oregon's coastal environments are not only super dynamic sort of at the modern scale, but if you look at really long periods of time, really incredible amounts of change have happened to the coastal landscape. And I'll give you an idea of what that's like through the research that I do with some of my colleagues. So it says here, the host has disabled attendee screen sharing. So I need somebody to click that on for me. I think, Cynthia, that might be you.
Try it now.
Okay, all right, looks like we're gonna get there.
There we go.
Okay. Okay, hopefully, I think everyone can see. So searching for early archaeological sites on Oregon's coast. And let's just jump right into it. So this what you'll see here is a map that shows the Pacific Northwest during a time at 16,000 years ago. So this is a time when global climates were very different than now. You have a lot of the world's hydrological budget is actually locked up in terrestrial ice. And so to make ice sheets the size of Canada, that water budget comes out of the ocean. And it normally does now in the sense that you have vapor come off the ocean, it turns into clouds, it turns into precipitation on the land. But today what happens is mostly that water will cycle back through to the ocean. During an ice age, the planet is so cold that the water arrives as snow, let's say, interior, and doesn't melt and return to the ocean. So over time, you draw the world's oceans down. So in our part of the world, you can see here, my cursor is on Oregon, and look at this extra coastline we used to have. We had a lot of really extra landforms to the west of where we are. And Cooper's Ferry is this orange box here, and this is an archaeological site I worked on for many years. I taught an archaeological field school through the anthropology department. And we take students out in the field and we teach them how to do archaeology excavation methods and recordation methods. We live in a field camp for sometimes 8 weeks at a time, and it's a pretty intensive process, but that's how you really learn to do archaeology well from the field. What also is in this image is it says closed until 14,800 or later. So there was a gap between the ice sheets in Canada that theoretically people could have walked from Alaska down through this gap in the ice known as the ice-free corridor, and they could have exited in what's now Montana and the Dakotas, and that's how they could have gotten from Northeast Asia. So we know that the native peoples of the Americas share genetic heritage with people from Northeast Asia, and that includes Russia, Mongolia, China, Japan, these kinds of areas. And so generally, that's the heritage origin. But what we don't know is how they got into the Americas exactly, because you have this giant piece of ice blocking for most of the last ice age. But what we learned from Cooper's Ferry excavating here is that humans are here by 16,000 years ago. So that sets up a logical problem, that how in the world did they get south of this ice before the ice-free corridor was opened? And you probably already guessed the answer, and very likely they came this way. They probably came down the coast. And in doing so, they would have been able to move on foot on land that was already exposed, but there would have been areas they would have had to use boats and paddle around ice that was grounded on the continental shelf and so on. So this is a very dynamic environment also along the northwest coast of southern Alaska, British Columbia, Washington. We don't know tremendous number of details about this area. It's kind of hard to measure. But what we do know logically is that you can't wait for this thing to open up, this ice-free corridor. You have to have people move another way. So the archaeological record related to this is out here on the coast. And Oregon is basically the area where you have the first left-hand turn, the first off-ramp to get off this. And that's probably why people are at Cooper's Ferry. They probably moved up the Columbia River Basin and settled in there. We also think that they probably would have kept going in their migration, and we expect there should be early sites out on the coast. But the problem is, during the end of the last ice age, all this ice went away and caused sea level to come back up. So it submerged these areas. Okay, that's a lot of background stuff, but let's go ahead and keep moving. So when you go to the Oregon coast, you can find archaeological sites, and you may have seen these before. So this is out at Cape Arago, which is near North Bend, Coos Bay area. And all this white material are shells and pieces of bone, and there's stone tool material in here as well. And it's exposed on the edge of the bluff and the beach here. And you'll see underneath it, there's a brown layer, and that's a soil that had once been at the Earth's surface, but has through time become buried. And let me say this, just so you're savvy sort of users of the coast from an archaeology point of view. If you find artifacts or find a layer of shell like this, do not dig into them because they're protected. Turns out we're not making any more archaeological sites from the past, right? So Those are all, it's a finite resource. So we don't want to be, you know, messing with these kinds of things. They're great to look at. It's really fun to find them, but take photographs, don't take items. That's a better way to do it. So anyway, my colleague here, Michelle Punk, is pointing at a soil that is present before people were depositing shells here. And these shells began at about 5,000 years, 4,000 years or so ago, which lends itself to some confusion. People ask the question, well, why weren't they eating shellfish before 5,000 years ago? Like, what is it about, you know, either the people here or the environment? And again, you may have guessed already, the problem is the best place to find invertebrates like this to eat are right on the edge of the littoral zone. So right on the edge where the tidal zone is. And the tidal zone, under changing sea levels, used to be way out to the west. It used to be, in fact, almost 30 plus miles away. So these kinds of sites are probably out there somewhere to the west under the water. We just don't see them until sea level arrives in its modern position about 5,000 years ago. So that's when we begin to see them on Oregon's modern coast. So if I'm trying to find sites that are 12,000 plus years old, I have to begin to understand this landscape looks very different. Okay, so what I'm going to show you now is a reconstruction of what the central Oregon coast looked like from 20,000 years ago to today. So I'm going to click on this and it's going to go through 1,000 year cycles. And we built this model using a software program known as Geographic Information Systems. And we basically, if you don't know what this is, it's a program that basically deals with map information. And so we went to archives and got information about the depth from the surface of the ocean down to the seafloor. And we reconstructed basically the shape of the landforms that were there to a certain depth. So the extent of our depth here is about minus 130 meters. That's about the maximum that the ocean went down in the last ice age. So what we're going to do now is run the movie, in a sense. We're going to show you 1,000 year time slices, and then we'll talk about it afterwards. So as you see, the landscape is changing as sea level's coming up. It's getting closer and closer to our modern coastline. And notice how we have a really big bay right there. Then we have islands. And then the islands get very small. And then Oregon begins to look like a straight coast after about 9,000 years ago. So from about 9,000 years ago to today, Oregon's coast has looked pretty similar. And it's only till about 5,000 years ago and today, it looks almost exactly the same as we see it now. So when next time you're out at the coast and you're looking out at the ocean, imagine that that vista is only 5,000 years old. It didn't look like that before that time period. And so you can see these contours that are left behind. So these are sort of our targets when we start to think about if people were here on the Oregon coast, this would have been their world. They would have been able to go out and access all this stuff and interact with it. So sometimes people would say to us, well, geez, finding these early sites shouldn't be hard. Just get scuba equipment and go out there and start to work on it. So here I want to show you, this is a sea level curve for the planet as a whole. And it is more complex to calculate this, but this is a simple model. And if I'm interested in finding evidence, let's say between 16,000 and 18,000 years ago, I have to go to places that are about 100 to 110 meters below surface of the ocean. Now, if any of you do scuba diving, you know that the limits of normal scuba are up here. And so to do the other 80, 80 meters or so below that, I mean, that's a real problem. In fact, you have to use technologies that are very expensive and a lot of technical difficulties to do them. And it's quite hazardous to put people down over and over again on the bottom of the ocean to look for sites. So this is not normally the way we would do it. What we do instead is I have worked on some projects where we are trying to map that landscape offshore. So we've used OSU's research fleet. We worked on the Pacific Storm, which is one of the vessels that was in Newport in our fleet. And we drag around equipment offshore. And what we do is we want to map, if we can see the surface of the seafloor, that's great. We can get it in better detail. But we also want to look into the seafloor. And we want to find evidence of things like this. And in this drawing, this is meant to be the cross-section of, let's say, like a river channel. because we want to find these kinds of landforms because it's places where people are attracted to live. And then once we get this kind of information together, and we do this by, these are the transects that we used on one of our cruises. You were out there literally mowing the lawn in a ship. And this is like a 10-day cruise, which I need to tell you this too. I get hideously seasick, and I had no idea until I started one of these cruises, and I'm stuck on this ship for 10 days. It was really brutal. But we got really great data. And what we did is worked offshore of the Umpqua River and the Siuslaw. So this is Florence and Reedsport down here. And I'm going to show you some of the data that we got from west of Reedsport. So this is what one of our instruments gives us. And what it does is it punches an acoustic signal into the seafloor, and then it reflects back differentially depending on the density. And so what we can see in this line, this is scale up here, it's 5 kilometers. So this is a really big transect. So as we moved from north to the south, we could map the seafloor, and then inside, eventually we would see this shape right here. And I've colored it here, and this is the inside of essentially river channel. So this is the Umpqua River as it used to flow out on the continental shelf. So we could actually find these ancient terrestrial features as they exist. And here I just put the depth markers for, at this elevation, it's 14,000 years ago. Here it's 11,000 years ago. So if we're trying to find archaeological sites of a certain age, let's say close to 12,000 years ago, I might want to be looking around the edges of these kinds of features. We then moved on to using different vessels. We work with Scripps, Oceanography Institute, or Institute of Oceanography. And we use this special vessel, the Roger Revell. And what's special about this one is that it has dynamic positioning. What that means, it has these thrusters on the edges of the ship, that allow it to sit on a specific square meter of the ocean. And so this is really critical, because what we want to do is use the equipment on this to lower something down to sample a very specific part of the seafloor. And here's our crew. This is me right before I probably got seasick and wasn't feeling great, but I look okay. I look a little grim, actually, like I'm on the edge of it. But I work with lots of different people from different institutions. And these projects, when you use these really big ships, often you have big collaborative things that go on, because there's no downtime, because the ship time is very expensive, and it's a big sort of professional organization. So it runs 24 hours a day. You always have something going on. And some of you are maybe on career tracks where you're going to get to go and work on these platforms. And they are really amazing, really, really cool things to work on. But what we wanted to do is focus on trying to see if we couldn't find evidence of, first, terrestrial deposits that is related to the time when water had not yet submerged the surface. We wanted to find evidence of that in this part of the coast. And then we also wanted to see if we couldn't find archaeological evidence, that is, artifacts that people had left behind. So we went to this very specific spot with the Roger Revell, and we also parked the ship so we could try to drop instruments right on the edge of this channel. So we've been around the edge of the river, so to speak, in the past. And we used a tool called a vibrocore. And this is a big motor that vibrates really violently. And this is the bottom of it. This is the weighted shoe that goes down and sits on the seafloor. And they would use this instrument called an A-frame, and you put the motor on top of a pipe, and the pipe then goes on the shoe, and you lower it down to the seafloor as the ship is sitting over your square meter that you're interested in. And you try to get that thing to land, and then they flip the switch, and it pushes this pipe into the seafloor, just the weight of it. And it depends on the density of the sediments, how far it'll go. But in some cases we could get, we got 4 meters was I think our best push, but most of the time it was closer to 2 meters. And there's a lot of sand out there on the continental shelf of Oregon, so it's really quite difficult to push through. So we got about 90 of these cores by working over a long period of time, and we brought them back to OSU, and we've since cut them open, and we've been examining them to see if we can understand what's inside. Have we actually found parts of the ancient landscape? Have we found artifacts? So we're still working on this right now. The work isn't done, but we're getting pretty close to being finished. So that's the offshore stuff. And the offshore stuff is very sort of theoretical, and it's sort of pushing the boundaries of method, and the success rate may not be very high, but we learn a lot of things in the process. But in the meantime, when I'm not doing things like this, I also work above sea level, because the landscape of, let's say, 12 to 15,000 years ago or something also was present on our modern shoreline in the past. So here, this is just a view of Newport. I'm not quite sure why I have it doubled here, but anyway, what we see here, here's Newport, and this would have been the amount of coastline that was present out here all the way to the glacial maximum. And we've modeled the Aquinnah, actually the river actually flowing out in this direction. So knowing that in the past, if let's say the 15,000 year shoreline is here, people may have come inland. There may have been inland attractions, things that got them to come in to do different activities, and they could have left behind artifacts for us to actually measure their presence. Because Newport, at this time in the past, is essentially the upper part of the river basin, whereas today, Newport sits on the lower part of the basin today, just because sea level has come up. So I just throw this in here because I think everyone knows that there's a subduction zone off of Oregon's coastline. You know, the seafloor is being pushed under the edge of Oregon, but what this ends up doing is it sort of rumples the edge of Oregon like a carpet. So think of it that way. It's pushing Oregon's coastline up slightly, but it's also deforming it in different ways. So there's these little small lines that run perpendicular to the big long one. And these are local scale faults, and they make different parts of Oregon's coast go up and down and tilt. And I like to think of it as Oregon's coast geologically is essentially a really big broken piano. A whole bunch of piano keys. Think of these isolated faults as piano keys, and then they're kind of rising up and doing different things. So this makes our work really quite complex to try to find archaeological sites, because you work in one river basin and figure the geology out, and the next one south is entirely different. So you have to sort of start over, but that's part of the fun of it too. All right, so here's a shot from Google Earth of Newport, and specifically this is the South Beach area right down here. Here's the boat basin, and there's the Bay Bridge. Okay, so what I'm going to show you is sort of a way that I might think about deconstructing this landscape and where I would want to look for archaeological sites related to, let's say, this very early time period I was mentioning. So we know there's a fault that runs through, this is the Aquinnah Bay Fault, and this is why there's a big embayment through here, is that basically the bedrock is doing some different things. I think the next slide will hopefully show us. Nope. Okay, so this side is down, this side is up. So this basically does like this. This side goes down relative to the other one, and it creates what's called an accommodation space. So this is a big negative space here, and it's where water will preferentially flow, and also it accumulates a lot of sediment through here. So if you were to push a core down through this part of the basin, you'd actually get a really long record, because that's where it's sort of filling in and accumulating. Like the floor of the elevator is going down, sort of right here. Here's the modern beach. I would not expect to find archaeological material related to, let's say, 15,000 years ago on the modern beach, because the age of these sediments here are, this could have been a trivia question. What is the age of the sediments on this part? It's whatever the last tidal cycle was, so less than 24 hours old often. Like they got deposited here or maybe removed very recently. So this is not a great place for us to look. Excuse me. Dunes and wetlands are behind the modern beach. This is a real common pattern in Oregon. So you get 4 dunes, and then behind them you get the dunes start to block drainage, and you can get low wet areas through here. And these deposits are probably not necessarily that old either, but it's not entirely sure. I maybe would want to look in here a little bit. The modern fill and wetland that's around the boat basin and where the Marine Studies Initiative building is, this is all pretty new. There's a lot of sediment that has been brought in here. If you look at historic photographs, for example, you can see areas that didn't exist, 100 years ago in here. And there's also a lot of wetlands, tidal wetlands through here. This part, because I was mentioning the floor is kind of falling out, this was pretty recent sediment. I wouldn't expect to get really early archaeological sites here either. So this sort of leaves us with this spot, this orange spot. And this is probably the place I would expect to find good archaeological information, where sites could actually be preserved here. And let me show you an example why I think that. Oh, sorry. Last part. I think the reason why this hard line exists between the uplifted marine sediments and these more recent dunes is probably because the Aquinnah River probably cut through here at one point, creating this sort of low area that the dunes have accumulated. Before they put in the jetties, the rivers are like, you turn a fire hose on at really high pressure and they just go all over the place. So the jetties basically constrain the flow of the river and create a navigable channel that's very predictable. That's obviously why these things get put in here. But before that happens, they will go all over the place in the road. So that's my guess. So why I say all this stuff is that looking for archaeological sites is like looking for a needle in a haystack. But in this case, it's like looking for a needle in a million haystacks. You really have to narrow it down to where you're looking. You can't just go and dig a hole anywhere and just go, well, maybe I'll get lucky. Well, it's better to be, it's okay to be a little lucky, but you should be a lot more smart is what you should be. So you got to sort of figure it out a little bit. Okay, so this is a shot of an eroded bank right next to the town of Port Orford. And I'm just going to show you an example of how we might look at the layers we find under the ground. So here I've put an overlay on it. This is the modern soil that's developed in a dune. You can see these lines here. These are pretty classic, dune bedded deposits. We have a radiocarbon date that we got off a piece of charcoal that was here. So it's about 5,000 years. And that's what we would expect, because modern shorelines arrive at their position today close to 5,000 years. And when they do that, they bring the beach close to the modern edge of the shoreline, creates a lot of sediment that is pretty loose, and wind just blows the sand and makes dunes all over the place. So a lot of the Oregon dunes are about 5,000 years and younger. There are some older deposits sort of in the middle of the big dune complex that are quite a bit older. But, if you had to bet on what the age of these sediments are, all up and down the coast, dunes are typically 5,000 years and younger, more or less. This is alluvium. Alluvium is a word that just simply means these are deposits that are deposited by moving water. So this is probably a stream, a floodplain. So if I wanted to try to find a site here, I would look at probably this kind of contact where this floodplain is older than 6,000 years. And I don't know the age of it, but that's where I would begin. This bedded marine deposit underneath it is probably not good either. And the reason for this is that this is really old. This is going to be 30,000, 40,000 years or more. And these are all being pushed up by that subduction zone, rumpling the edge of Oregon's carpet, so to speak, and pushing these seafloor sediments up above sea level. So these are not the areas I want to look either. But it's like the Goldilocks concept, too young, too old, just right. Probably right here in the middle. Here's another one that's from a place where we have a lot more information about ages. This is a place called Indian Sands, and this is down near the southern Oregon coast, near Brookings. And this is a dune, an ancient dune deposit. So all these things are wind-blown deposits. This is dune sand. But when we have that really big open coastline with 30 extra miles or so of Oregon's coast, we also have rivers that flow across that, and they bring out fine sediments like silt and clay. And the wind will push those sediments back onto the shoreline, so onto the modern shore. So we often get these really fine sediments, and these are called loess. L-O-E-S-S. So this is windblown dust. So this is dust that shows us basically 26,000 years ago, you had the shoreline way out to the west, and basically it was a very dry and dusty environment. Then we get a shift back to dunes, and eventually it goes a little bit to loess again. So we excavated here, and we actually found archaeological evidence of people living here between 10 to 12,000 years ago. And mostly because we narrowed down and found the dirt of the right age. So that's what we were doing. We're trying to narrow down, where is that layer? Where might we find it? And we actually found artifacts in this. So this is the earliest archaeological site on Oregon's coast, is at this place. So again, if we go back to thinking about this, where would we want to work here? My money is on this area, probably close to, if this was actually an ancient channel cutting through here, we may want to look sort of on the edge of this. And when you look at Google Earth, you can tell there's different sediments underneath the vegetation. where people have made construction projects, the sediments in this orangey patch are actually sort of orange and red, which typically is like we saw in the last image, that signals older kinds of sediments that could even be loose underneath here. And then this one, the aerial image shows us is mostly a yellow to white sand. So that's probably going to be quite recent. How will we do this, and how does this have anything to do with Ocean11? Well, I'm going to start doing some projects around Newport, and we own this machine. This is called a Geo Probe, and what we do is a track-mounted drill rig. So I have a handheld remote control. It's an 8,000-pound RC vehicle. It's pretty awesome. So we walk that thing out to where we want to sample, and then I set it up, and we push steel pipe down in the ground, and there's a sample tube inside the casing. And as we push it down, we can retrieve back up a column, like a straw, basically, that's 1.5 meters long that has a column of the sediment inside. And so we get, think of it almost as like a reverse periscope. We're looking under the ground, and we can bring the sample up with us, and then we can look for archaeological sites. And if we actually find one, or we find the dirt of the right age in some of these places, then we focus in and we shift. Oh, sorry, here's an example. If we pushed the core down through this kind of deposit, we would find these ages, and we would also maybe find artifacts in that core. But if we do find a site that's buried, or we find a target deposit, the dirt of the right age, then we might shift to using these techniques. And these are more archaeological techniques where we go in by hand and use shovels and trowels and sometimes hand augers. And we bring the sediment up and we screen it, and we look for artifacts. And we also try to find artifacts in the floor. So having people participate in these kinds of projects are things that I'm, offering to the group. If people are interested in doing these things, I'll get them organized, and I can communicate with your group. And if people want to come and see it, or if it's something that intrigues them, they want to do more of it, I'm happy to have people help participate. And we're also going to do more stuff out on the Siuslaw National Forest that is near the dunes. So we're going to be out sort of exploring in the dunes. So that could be things like surveys where we do hiking and go out and look for buried soils, buried forest soils that are under the dunes and so on, and maybe even archaeological sites. So there's all kinds of great outdoor activities that go along with archaeology. We're taking a big break from those right now. Normally this is the time of year where I'm out running around doing all kinds of things, but now I get to catch up, and I get to make presentations like this and maybe try to get other people interested. So that's all I had for a presentation, which I suppose is a lot, but maybe we want to shift over to questions or something. I don't know what you guys want to do now, but I'm going to stop sharing. So
That sounds good. Does anybody have any questions? Unmute yourself and ask a question.
Yeah, I had a question about the cores that you would take from the boat. You said you took what, like 90 samples. I was wondering how many of those actually contained what you were looking for, like an archaeological site or something else.
Yeah, so far we have not been able to actually get any archaeological material. And I showed you that image of where we could see buried surfaces and see that channel. But the problem on Oregon's coast is that there's a lot of sedimentation that happens out there. So we have not yet been able to punch through that marine cover. We can see it, we just can't touch it. So this is part of how the research process goes. Like, we know it's there. Using these pieces of equipment, we just couldn't get there. So then you go back and say, we need a bigger shovel, in a sense. Like, we got to figure out how to sample that thing. But thanks, that's a great question.
Okay, I've got one. Could you talk to us a little bit about the types of artifacts that, if you do find them, like, what are you finding? Are you looking for specific things in specific areas? Yeah, I'm not really sure how to approach this one, but maybe you can.
Sure.
Why don't you say your name, Nico, and what your major and year and stuff like that?
Oh yeah, that's great.
Oh, okay. I'm Nico. I'm a first year. I'm studying something in the College of Engineering. I think technically I've got till the end of the year to, like, officially declare it. So we'll wait until then for certain. But yeah, I just had that question about artifacts or archaeological artifacts or whatever you're looking for, because I can picture the digging and the sample taking, but you know, what is it really that you're looking for? And
Yeah, right. So if you all, you know, in the place where you're sitting right now, you sort of look around, and the things that surround you are many artifacts. You know, artifacts by definition are sort of things that humans have modified to create an object. So like where I'm sitting, I've got a desk and I have, you know, a coffee mug, and I've got all kinds of things. But these are made of different kinds of materials, you know, and so some things that are organic, like wood items, don't preserve that well. So if we imagine what the life ways of these people were like in the past, they're hunting and gathering and fishing, and they make their living from things that they get from the land, and all the items that they use and wear and the houses they might live in are from, you know, organic items or inorganic items that they gather, you know, from the land. So the things that preserve really well are often things like stone tool material. So finding stone tools are often some of the best ways of knowing that there's an archaeological presence. On the coast where it's really wet, especially in deposits that are wet all the time, you can actually find organic items. So there have been instances on the coast where people find carved wooden objects, carved bone objects. And, but those are pretty special situations because normally they just decay over time. So for our case, because our cores that we use are not very big, you know, we probably are just hoping that we're gonna punch through a layer that has maybe like some shell, and then if you could find like a piece of bone, and then you could find a little tiny bit of stone that shows it was actually flaked or broken to make stone tools. There are sort of geometric characterizations you can look for. You can look for the way it's shaped, the way it's flaked, to make an argument that this is an artifact. It's not just a piece of gravel. You know, so also too, I mean, we as archaeologists, we spend a lot of time learning about how to make stone tools. So you know the difference between, you know, students often when they're starting out, they bring me rocks and go, is this an artifact? It's like, well, no, not quite. You know, it'll help them understand what really they're looking for. So we just got to find some kind of evidence that people modified this organic or inorganic object. And so let me see. So at my desk here, I've got, this is a model of a spear point, for example. It's made out of plastic, but it was originally made out of rock. And so someone took a block of rock and they actually hit it in very controlled ways to flake it down, like they're sort of doing sculpture. They flake this thing down to this particular shape. And then they used it to hunt something, and maybe they either lost it or it became broken and they didn't want to use it, and they just throw it away. So, and then they throw it away, then it becomes part of the archaeological record and we can find it. So what we want is to find those places where people are hanging out a lot and making a tremendous mess. In fact, the messier, the better. You know, the people that don't really clean up and they make huge messes, like the hoarders and, you know, real sort of, you know, pig pen kind of people. We love those people because they're really easy to measure in the archaeological record. If you're really clean and you clean up everything and you take it out to a landfill and throw it away there, it's really hard for us to measure what you're doing. So it's kind of basic, I guess. But so we can look for that. There are other techniques now that are used where the cored sediments, even if we didn't find an artifact, let's say we found what we thought was a buried soil, that is evidence of a terrestrial surface that now is buried under the seafloor as sea level came up and submerged it. There are techniques where we work with other scientists and they will take a little tiny sugar cube sized sample of sediment and they will run all of the DNA that's inside it. And they will tell us who, you know, biologically, who lost tissue, basically who lost their organic content. And that could be because they bled or decayed or went to the bathroom or whatever, but they lost cells and they lost DNA, and those can be preserved. So there are projects where they've done this and they can reconstruct the plants, the animals, the insects. I've not heard of cases where they find human DNA, but it's not impossible. So that, you know, that's a long shot, but you know, like if you were to find human DNA in there, you'd have to make sure that it wasn't contaminated by the people working on the core, but there are ways to prove it.
Thank you.
Yeah. These are great questions. More questions?
Yeah. I'm Drew. I'm a third-year marine bio student, and kind of along that same vein, is there anything that you've like found in your career that stands out as like a career highlight? Like if you had a highlight reel of
Yeah.
the things that you've done, is there anything that sticks out as particularly interesting to you?
Yeah, I mean, I can think of several of them, but one I think that's relevant to this group is, it was mentioned in the beginning, but I work also in northwestern Mexico in Baja California. So it's the northwestern state in Mexico known as Baja California. And then we work on an island that's halfway down the peninsula in the Pacific side. It's called Cedros Island. And Cedros Island is literally a desert island. There are very few trees, around it. And as you walk around, you can find a lot of artifacts. But as we've worked there through the years, we've actually been discovering that people were making shell hooks. And let me show you an example. This is not one from Mexico, but this is one last year I went to Maui. And so, here's an example of a shell hook. And people make these in this case, it's made out of abalone shell. And we find ones in Mexico that are made out of abalone shell. And in this case, it's sort of like a bread bag tie style, where an animal with a very hard part on its mouth. So think like groupers and bass, sea bass, stuff like that. They bite this and it pinches on that joint. And when they pull back, it's almost impossible to take it off. You have to almost cut it off. So we found a lot of these actually on the island, and then we started to get radiocarbon dates on the shell material, and they came back very early. In fact, we found the earliest evidence of deep sea fishing is on this island, and it's about 12,000 years old. And we then found the bone of the fishes that they were catching. So in some cases, they were catching black sea bass, which can be 400 pounds, these fishes, or they were finding barracuda. We find tuna, other ocean whitefish, halibut. So in some cases, these people are actually catching, probably with hand lines made out of plant material. So you sort of weave this together, and this is agave plant, which has very strong fibers. And they fish down the water column, catch a fish that probably weighs more than they do, and they haul it up into the boat and then bring it back on shore. And in the case of that island, we can find these sites because water is a real limiting factor. So they actually will carry the fish miles inland to sit around a spring, because the water, 8 pounds of water gets you about a day. That's a gallon of water. 8 pounds of food can last many days. So they bring the food to the water, fortunately. So we've been finding these sites around these springs, and it's really pretty amazing way to actually measure deep sea fishing. Well, any other questions? Did we wear you guys out already? And it's been kind of a lot of information.
No, it's been great information. Really good.
Well, and like I said, I'm interested in having, providing opportunities for people to, maybe come and visit with us or try things out and see things. I'm really into experiential learning. Let's go and do stuff. We're, like I said, we're taking a break on some of that stuff right now, but I imagine maybe in the fall when things are back rolling again, we'll have some opportunities to do that stuff. And I would probably set it up as, give you guys information about we will be out here at these days. And it's not a lot of obligation. You don't have to make big commitments. You can come out and see it or visit it. If it's something you like, you can get involved with doing more and more. So it's sort of as people like.
Well, that would be great. We could focus a field trip around it or something like that, or have signups to help. That would be super, Lauren.
Yeah, the Geo Probe is tons of fun because it's instant science. You push a pipe in the ground and pull out history. It's pretty amazing. You crack that thing open and you never know what's inside it. I always feel like it's Christmas every time we pull that thing out of the ground. So.
John, wrap it up.
Okay, John.
Alrighty.
Wrap it up.
Well, thank you, Dr. Lauren Davis. We really appreciate it, and I do look forward to coordinating some events where we can work together and go dig up, history / use an 8,000-pound RC toy, because that sounds really fun.
You never know.